Hello there, students from Beehive School. This is teacher Krishna, and welcome to our physics class for week number 13. Before we start, I would like to thank you all for attending all of the online lessons that we have had for you, and as well for completing all of the exercises that we have given to you. They are going to help you a lot to keep track of your learning process, and of course, they're going to help you to keep on developing your professional skills. So keep it up, and I'm pretty sure with time we're going to be getting way more used to this new methodology and way of working, and you are going to be developing even better. Okay, so before we start, let's just follow some general instructions. Log into Agilex, enter your Google Classroom, download your Word document, and name it as it is specified right below. The only difference this week is that you have to write down week number 13 before the rest of the name of the document. That is going to help you out to keep track of the order of the lessons that you have taken online with me. Okay? So as we move, remember to take notes on the Word document. That is very important because that is going to help you out to keep track of the most important things that you are going to learn during this video. And as always, it's always important to start with our end in mind. The topics we're going to study this week are topics 2.05 and 2.06. Our end in mind for the week is the following. The students will be able to manipulate equations to isolate a selected variable in order to complete velocity problems adequately. Alright, so that is the first thing you need to keep track in your Word document, so make sure to copy it and come back to the video once you are done. So the first topic we're going to learn is manipulating equations. So now we're going to start going deep into the manipulation of equations and to physics itself. And manipulating equations is extremely important. Why? Because presenting an equation in an alternative way or an alternative form is essential. Because in physics, you are always going to have like a base formula. But once you start reading the problem that you have been presented to, you might find that the formula is not really arranged according to what you want to find. So in order to complete the problem and find a solution for what you're looking for, you need to manipulate the equation a little bit. So today I'm going to be giving you some tips on how to manipulate them adequately. And we're going to start with a very simple example. And this is an equation that is used for finding momentum. So here you go. P equals momentum, M equals mass, and V equals velocity. So, and let's suppose that you do not really want to find momentum because that is something that you already have. So what if you want to find velocity? Okay, so here is the first tip. Let's say that you want to find velocity. So the first thing that you need to do is isolate the letter V, because that's the one that you need. Okay, so how are we going to leave letter V alone? So basically, what you can see here in the example right below number 1, you can see that we divided both sections of the formula by mass. So that is possible to do in physics because if you divide both parts by the same data or by the same, let's call it value, then nothing is really going to happen. But it is going to help you to manipulate the equation. So, okay, now you already divided both parts of the formula by mass. Okay, so now if we look at our formula on the right, you can notice that there is a mass at the top and mass at the bottom in a division. So what happens in a division when you have the same value at the top and at the bottom is that you can simply eliminate it and subtract it from your formula. So here you go. This is the result when you already isolate velocity. So velocity equals momentum divided by mass. So this was a very simple example. But I would like you to go to page number 1 in topic 2.05 and analyze the second example that is given to you right there. So that is going to give you a better perspective on how to manipulate formulas, right? So go ahead. When you are done, I will be waiting for you. Alright, so let's continue. Now I have another example for you. So as you can notice here, it's a little bit more complex. So here we have a formula at first in which t equals 2p square root L divided by G. So now what we want to isolate is letter G. But now in this case, it is going to take us a little bit longer because we need to eliminate a couple of things before we isolate letter G from that formula. So the first step will be to square each term. But why are we going to square each one of the terms from the formula? Well, it happens because we have a square root almost at the end. And L divided by G is surrounded by that square root. So how are we going to eliminate it? We're going to eliminate it by squaring each one of the terms. So here is the result. So t to the second power equals 2 to the second power times p to the second power, and we multiply that by L divided by G. Alright, so now we can start playing a little bit around without that square root that we have in there. So what is next? We have to multiply each side by G. Alright, and we already have the result in there. So if in the right we multiply that by G, we're going to have 1G at the top and 1G at the bottom. And remember what I told you about it, when we have a division and we have both in both sides, right at the top and at the bottom, the same value, we can simply eliminate it. So that's why there is not G anymore in the formula in the right, but it is on the left. Alright, so now we are almost done because we already isolated letter G. Okay, but you can notice that there is still something that is bothering us in the formula. It is t to the second power. So now we can divide both sides by t squared or t to the second power. So once we divide it, you can notice that we can eliminate t squared on the left side, and you can notice that it is added on the right side. So that'll be the end of the rearrangement of the formula. So now we already have our isolated G. So this is an example of a little bit more complex formula, and notice that you really need a lot of practice when it comes to rearranging formulas, because it might seem a little bit simple at first, but I have noticed that students start having problems when they encounter more difficult formulas like the one that is presented in here. So that is why we're going to have some time to exercise, and if you're having problems on how to rearrange or how to isolate one of the specific variables, don't worry, you can contact me on Google Classroom or in the Zoom meeting that we're going to have later on. So here we have a small review on what is suggested on this kind of rearrangement. So we have to eliminate any fractions in the equation. We have to isolate the desired variable, follow simple algebraic manipulations, show all steps involved in manipulation of the equation. This is very important because I think I mentioned it last time, but there are very smart students, just like all of you, that try to do everything as quick as they can. And they don't really write down all of the steps that I have taken when rearranging or isolating the data. So that takes them to make some mistakes. So it's better if you specify each one of the steps that you have done in order to find the solution for the problem. And of course, lastly, check your work and leave a fraction in the denominator. Okay, so I don't know what this is duplicated. I'm sorry. Let's just continue. There you go. Exercise. So now, go to pages 2 and 3 of topic 2.05 and complete 4 problems from both pages. So now this is your time to start working on the rearrangement of formulas. So it might be a little bit difficult at first, but I will suggest that you try it out without the results that you find in Agilex. So at first, try it out by yourself, and if you're really struggling a lot, you can check the results from Agilex. Or if you want to, you can contact me in the Google Classroom and I can surely help you. So in total, you need to complete 8 exercises. 4 exercises from page 2 and 4 exercises from page 3. So good luck. Once you're done, you can come back and we will continue with the next topic. Okay, so our next topic is velocity. So this is a very simple topic, but there are some key aspects that we need to analyze. So the first thing we need to analyze is that velocity is a vector. Thus, it has speed and direction. Some students tend to confuse speed with velocity, and they are totally not the same. Because speed only has a value like kilometers per hour or miles per hour, but velocity has that value, but it also has a direction. We're going to see some examples later on. We also have constant velocity. It happens if an object moves at the same speed and the same direction. So remember, since velocity has direction, we need to have a constant speed in a constant direction. So if any of both change, then that will not be constant speed. We have a change in velocity. It can occur when the speed and or the direction of the object change. This is what I was telling you about before. So probably an object can have the same speed, but if it changes the direction in which the velocity, or most likely the speed, is being applied to, then it will have a changed velocity. Okay, and here is an example of a car that shows a certain velocity. So you can notice it is moving and it has a certain speed, but it also has a direction, so that's why it will be a clear example of what velocity is. Right, now let's go with some important terms. And distance versus displacement. So, and if we talk about distance, that is the, let's call it, let me give you an example of distance. Let's say 5 meters. But if we talk about the displacement, then we will have a value just like the one I gave you before, but I will also have a direction. For example, 5 meters north. So just 5 meters, like isolated, that will be just distance. But if we give distance a direction, then it will be displacement. And also we have to analyze the formula for average speed or average velocity. So we have that velocity equals distance divided by time. So probably some of you might be thinking, hey, I remember that this was the formula for finding speed. So is it the same as velocity? Well, let me tell you that you are right. The formula can be used for both. It can be used to find an average speed or an average velocity. But it depends on what context you are using it. But of course, you can use it for both. And also we have instantaneous velocity. So it happens when we measure the velocity of an object at a certain point of time. So we are not measuring all of the changes that it is suffering through the different amounts of time, but we're just taking the velocity at one specific point. And also we have to remember that units are very important. And here are some velocity units that you can take into account. You have centimeters per second, north, miles per hour, west, or meters per second, up. One more time, considering that we need to have a certain speed and also a certain direction. Okay. Now we're going to go with some analysis. So during a certain period of time, the speedometer of a car reaches a constant 60 miles per hour. Question: does this indicate a constant speed? Explain your answer. So we can go back one more time to this statement, and it says during a certain period of time the speedometer of a car reaches a constant 60 miles per hour. So here's the trick. Of course, it shows a constant speed because just like it's mentioned, it has a constant 60 miles per hour. Okay, and on the other case, does this indicate a constant velocity? Explain your answer. Well, in this case, it does not show a constant velocity because we're missing something very important in there. We're missing the direction where it is applied to. And if there is not speed and direction, it means it's not velocity. And next one, we have true or false. Charlie drove his car around the block at a constant velocity. Explain your answer. Well, let's imagine that we're talking about the block that is around your house. So you can imagine the path that is going to follow. And it starts in your house and it finishes in your house, which means that it will be turning around. So does it have a constant velocity? Well, that'll be false. Because remember, constant velocity means that it has the same speed and the same direction. And what happens is that if the car is turning around in order to go back to the same spot where it started, then it will not have a constant velocity because it is changing its direction. Okay? So now it's exercise time. Go to page number 3 of topic 2.06 and complete all of the problems that you will encounter in there. Okay? You can pause the video, go there, and once you are done, you can come back. Lastly, your evaluation. So before you take the evaluation, review topics 2.05 and 2.06 and complement the summary that you already have. And when you feel ready, you can take the evaluation for both topics. Remember, these evaluations are both 5 points for a total of 10 points. And that was the class for this week's. And I hope that you have learned and clarified different concepts related to how to rearrange formulas and concepts related to velocity. So that will be it for today. Thank you a lot, guys, for coming one more time, and I will be seeing you next week. Goodbye.